So there must be a significant around why so many companies like Spotify and Netflix are shifted to cloud native. So today I hope to explain some of this impact and hopefully make you consider building applications around cloud native. But I'm also going to explain why you should consider cloud native by comparing the traditional monolithic approach that allowed this shift to happen. I'm also going to review some case studies to explain how these technology help these companies balance all these challenges. And then we go into explain some of these terminology like microservice, container, and so forth. How does that all sound? Great. I hope it's shifting. Okay, so a little bit about me. I am Sully. I'm a software developer, also a AWS community builder. I am based in Boston. I'm all about simplifying things, all about the community. So hopefully this presentation helps you kind of glue all the dots together. Before I dive in, I do want to get a show of hands of who is using cloud native right now. Okay, awesome. We have a few of you. And how many are considering adopting cloud native technology? Okay, we have some new hands. Okay, awesome. So what is cloud native? And I'm sure you heard very different things. I would say that cloud native rose to fame in mid-2010, but officially it was founded in 2015 by Cloud Native Computing Foundation with this whole idea of promoting a efficient way of deploying and speeding up a lot of these processes. But essentially like fostering collaboration among your team and community. Essentially, this is just one of the definition, but to summarize, is allowing you to faster and efficient way to develop, deployed. It's a set of principles to help you build and run scalable applications around cloud. And they encompass these three things: the scalability, able to handle increased workload by adding resources to accommodate these demand; flexibility, able to adapt to constant change and requirement quickly and efficiently; and it's resilient, able to sustain functionality even when face failure or disruption in the application. So again, cloud native is not just a technical shift, it is a culture and organization change. So now let's explore some of these things in the monolithic architecture. So what is, sorry, what are you saying? Are you clicking here? Do you see the next chapter? Okay, awesome. So what is monolithic? Monolithic tend to be your standard way of applying, building an application. Is usually an easy way to do when you are just starting up. But a definition is essentially a very concise single code base for your entire application that holds all of your components like data storage, business logic, client facing, and so forth. And it's all managed in one unit. So if you was to change a code in one area of your application, it will require a whole redeployment of your application. So it's not the most advantageous intensive resources allocation. So some of the challenges that does arouse with monolithic, it is easy to develop, but it does become a challenge when you had to now coordinate your code changes with your team members. You have to figure out that your code changes are not impacting the rest of your team. So this could cause a lot of frustration among the rest of your team. It does become harder to scale, and I hope it is clicking, because as your team becomes bigger, you have to individually, as your application gets bigger, more complex, it does become harder to scale individually with this particular architecture. So it does require one small, and I hope I don't repeat it. It is clicking here, but it's not clicking here. It does reduce the velocity of the application because you don't have a lot of automation, and it does become a challenge. One small change of your application will require the whole application to be redeployed. It does take time to market because, again, a lot of complexity around your application. In this traditional architecture, it does are more prone to errors. So because you don't have a lot of visibility of how actually everything is running or how it's actually impacting the user. So I wanted to do something fun. I don't know who is a Barbie fan here, but I am. I wanted to kind of illustrate how the monolithic architecture will work in the Barbie mansion or dream house. In the monolithic, let's say Barbie wants to host a sleepover in one other area of the house. To allocate that, the monolithic architecture would not understand that it just needs to scale that particular area. It will instead recreate the whole mansion all over again just to accommodate the demand coming from that particular area. So as you notice, it will continue doing so to accommodate the 1,000 of guests that Barbie is hosting. So not the most efficient way of like resourcing, and it could be very costly. They had to build this whole mansion again. So imagine. So let's now illustrate, and let's continue going. So why go cloud native? Cloud native might not always be the best approach. I always recommend to explore cloud native when your team is becoming bigger, when your company, now your application's becoming more complex. It's time to scale up. Cloud native provide you a scalability. It's able to now accommodate these fluctuation of demand with no downtime or performance degradation. It's resilient, so it's able to now automatically recover even with face server crashes or network outage by distributing equally among all of the microservices. And it's flexible. It's able to now deploy across multiple cloud providers, and you can choose your infrastructure however you want or meets your budget. And it's efficient. Sorry, I went kind of ahead of myself. And it's efficient. It streamlines your development by setting all these automation. And overall, improving the experience from your developer because they don't have to do all this manual work themselves. You can set it up with Kubernetes to automate a lot of the deployment, scaling, and managing the performance of your application. So now in cloud native, the way it works is different. In Kubernetes or container orchestration, it will split all of your room to meet a specific business logic. So you see the kitchen, the bedroom, and all being separated by containers. So you can individually deploy it and scale it. So if now there is a demand coming from a house, it will Kubernetes will detect this traffic and start allocating just the resources to that specific area instead of having to redeploy this entire house. So now, how do they all work? So we hear microservice, container orchestration, but how do they all work together? So microservice, let me see if you guys have it here. So microservices essentially break in now your application into smaller, more contained, and you can individually deploy it. It gives you a lot of flexibility to innovate, but as your application becomes harder, it does become very complex to do so in terms of building. I mentioned as your microservices become bigger, it now becomes a challenge in terms of redeployment because you have the room to now build your microservices with different infrastructure. You can build it using Node.js in one, Java, and you name it. But this becomes complex in terms of how do you find a simple way to deploy it? And that's when containers come into the picture. And I'm always clicking at the wrong thing. Container essentially helps you deploy all of your microservice consistently and able to run in different environments. But when you have 100 to 1,000 containers, it's really hard to now monitor or observe how your application is doing. And so that's when containers orchestration comes into the picture, essentially manage manage how all of your containers is doing by auto scaling. So essentially now you can schedule how it's scaling, how it's deploying, how you develop your applications. And it's reliable. So even when it detects a crash on the application, it's able to there's no downtime, so it's recover itself. So it does provide this self-healing. So it has a backup in terms of if it does detect issue, it can restore it to its previous state until you implement these new changes. And now everyone is happy because everything is working officially. Now Barbie gets to host successfully her her sleepover. So let's understand these key concepts. I overview some of these things already. Microservices, essentially breaking down your application, is part of a bigger app and break it into business logic. You can have a microservice for your shopping cart, one for registry, depending on what makes sense for your business. And containers essentially is a portable to package all of your dependency, everything that your application needs in order to run efficiently in all of the environments. And Kubernetes is just an open source that allows you to manage and develop more efficiently and upscale your application. And then all of these tools gives you the visibility or velocity that you need. So now let's compare let's dive into some of the case studies. I'm not sure if you're familiar, but Trailup is essentially a Drift online store, and they were facing a lot of scalability issue with the traditional architecture. As the company began to grow substantially, their user pass was surpassing 20 million mark, and that became a challenge in terms of escalability. Sorry. They were struggling to handle this increased load of traffic, and so that was leading a lot of performance issue and this customer dissatisfaction. Holidays like Black Friday. So efficiency, they were and I keep on clicking this, efficiency, they were facing a lot of delays. In order to set up a new service, it was taking them about 2 to 4 weeks to get an environment going. And this were impacting a lot of the customer experience and trust. And then because of the limited resilience, it didn't really give them a wide scope of how their performance was doing or even detect some of these issues on time. So they had to, it was not the most way to function at this time. So it was very painful for the team. And it was high infrastructure costs with this traditional setup. So now how did Cloud Native help them solve some of these challenges? So they were able now to handle spike in traffic during the sale events like Black Friday. They are more efficient, able to now streamline their development and deployment processes. And they're resilient, able to now perform efficiently even during these peak load. And then it was more cost effective, so it reduced significantly their infrastructure costs. So by the number, you see that the deployment time was reduced to 50%, their hardware cost was reduced to 56%, and their new application rollout went from days to weeks to just minutes an hour. So these are just some of the quotes from the CEO. Essentially, Kubernetes allowed them to process or manage days like Black Friday, and they don't have to now intervene and do them themselves. So it allowed them now room for quality time with their family. So the next company is Plaid. Plaid is essentially a technology platform that enables applications to connect with the user's bank account. And some of the challenges that they were having is that they had very inefficient deployment processes. They will literally, their engineer will bundle up hundreds of PR or pull requests into one single deployment. And this was leading to now to self-services, slow feature release, and error pro deployment process. Because again, they didn't have the observability or monitoring how their these features were actually, or detect these bugs or issues on time. And now because of that, they adopted poor deployment process. So let's see how they solved some of these challenges. I'm not sure if you've heard of, I'm sure some of you have, the Canary development. The way that it works, that essentially helps you a safer way to deploy it using some of these three things: Argo rollout, which is essentially a controller designed to manage your rollout updates in a Kubernetes environment. Linkered essentially is a kind of like managed how your rollout is done smooth and efficiently by managing the different communication among your microservice. And then Nginx essentially controls the traffic, and it acts like a load balancer. So if it needs to roll back, if it does detect some changes, it could easily roll back to its old version. And this is a diagram how it works. Canary checksum is displayed between the blue and the green, and I think this is actually backwards, but essentially most of the traffic will go into the old version. That's what the user will see, and some small percentage will go into the new version. And it will be those small changes will be gradually deployed until it's fully updated. And the way that the advantages of this is that it can able to detect these changes or these issues around the application on time before it actually impacts the user. So it reduces risk and it minimizes the downtime of the application. And these are some of the quotes from the CEO. This allows to minimize a lot of the bugs tremendously, and they don't have to now have any manual or human intervention. So what are the benefits of adopting cloud native? It gives you agility, able to faster and develop quicker and hit the market compared to traditional. It's easy to upscale up and down depending on the demand, and by automizing the resources. And it's resilient. It's able to now operate efficiently throughout your application and able to hold these demand accordingly. And it's cost effective. You pay as you go, so you just consume for what you use. And now, as you see, as Barbie is able in this clip, able to adopt and transform herself effortlessly, and that's how cloud native is, or at least how I will describe it. Where to start? Where can you begin your cloud native journey? Cloud native could be very daunting. Like, it is a deep curve, but I will recommend Cloud Native Landscape. It gives you kind of like a roadmap of like how to build this foundation, and gives you resources in terms of certification and training. But I will also start off by saying that I will recommend everyone to start by learning microservices first, and then move on into container, and then container orchestration, and kind of understand how they all communicate with each other. But I didn't want to leave you guys hanging. I did provide some resources. This is free training courses in Lean Foundation. I recommended Introduction to Kubernetes. Also Introduction to Cloud Infrastructure, and those of you who prefer online courses, I always advocate for her. She's her name is Tech World, or her YouTube handle is Tech World with Nana. She is she always providing great resources, so I would recommend that one. And then for those who prefer physical books, I recommended Building Microservice by Sam Newman, and then Kubernetes Up and Running with Brandon and a few others, and these are the books. And then I also recommended some sessions because I always want to support fellows that are here at Civo. And again, and I'm probably bushing his name, he has a session today on how to scan out your Kubernetes cluster with local AI. That's happening today at Cowboy Pavilion. And then Dinesh in Garland is doing a session, a hands-on workshop on Kubernetes Unleashed mastering installation and configuration. That is happening today as well at 4 o'clock. And tomorrow, she's doing one on navigating unconscious bias by Cloud Native Police Support. And that's going to happen tomorrow in this room at noon. And today, I was a little nervous, but I hope you took at least 3 takeaway, how Cloud Native impacted these business, understand some of the differences between microservice, containers, and container orchestration, and now where to start in your journey. Any questions?
Can you please go back to the resources page?
Oh, sure. Oh, and I will also be providing the links on the deck, so I will make sure that I share the deck later. Any other questions? Thank you so much for attending.